Earth's long and turbulent history is marked by 5 major mass extinction events that reshaped the trajectory of life on our planet. These cataclysmic episodes, occurring roughly 445, 365, 252, 201, and 66 million years ago, stand out like deep scars in the geological record, each wiping out large fractions of the biosphere and clearing the evolutionary slate for new forms of life to emerge. The most recent of these events, about 66 million years ago, is famously associated with the demise of non-avian dinosaurs. For decades, the prevailing explanation has been the Chicxulub asteroid impact in what is now the Yucatan Peninsula, an event so devastating that it sent shockwaves through global ecosystems, ignited massive fires, and plunged the planet into darkness under a shroud of dust and aerosols that persisted for months or even years. Scientists still debate the exact interplay between this impact and other forces, such as volcanic eruptions, but the asteroid hypothesis remains the dominant narrative. However, a deeper and more speculative question arises when we consider not just the physical causes of extinctions, but the possibility that external, perhaps even intelligent, influences could shape the course of life on Earth. Some researchers have suggested that astrophysical events, supernova explosions, or the solar system's periodic journey through the dense spiral arms of the Milky Way might trigger environmental catastrophes or disrupt the stability necessary for life. These ideas remain on the fringe of mainstream science, but continue to spark curiosity and debate. Yet one possibility is almost never mentioned in scientific literature: the notion that life on Earth may have been intentionally seeded by an interstellar gardener, a hypothetical extraterrestrial intelligence that might intervene periodically to reset or recalibrate biological evolution. If such a gardener exists, and if it played a role in the origin of life here, then logically it could also have the means, and perhaps the motivation, to reset the biosphere whenever life begins to develop in an undesirable direction. This idea expands the traditional framework of panspermia into something more controlled and intentional, raising profound questions about whether the mass extinction events we attribute to natural cosmic randomness could, at least in theory, have been directed interventions. It is within this context that Dr. Robert Seikert's provocative question becomes especially intriguing. Was the Chicxulub impactor a predecessor of 3I/Atlas? This question fuses scientific curiosity with speculative imagination, inviting a comparison between the ancient asteroid that ended the dinosaurs' reign and the newly observed interstellar object known as 3I/Atlas. The reason this comparison sparks interest is that Chicxulub and 3I/Atlas appear to have similar estimated masses, despite being separated by tens of millions of years and radically different contexts. Chicxulub arrived without warning, while 3I/Atlas is currently not on a collision course with Earth. Still, the idea that an interstellar object could maneuver, could change trajectory in a deliberate non-gravitational manner, adds a layer of mystery, because natural comets or asteroids typically follow predictable paths governed by the physics of the solar system. As of now, 3I/Atlas is not heading toward our planet, but if future observations showed an unexpected shift in its course, that would dramatically elevate the relevance of Seikert's question. Was Chicxulub random, or could it have been part of a larger pattern involving interstellar visitors? And if 3I/Atlas behaves anomalously, what would that imply about the possibility of external intelligence? The curiosity surrounding 3I/Atlas has not been limited to scientists. It has captured public attention in striking ways, especially after Kim Kardashian, one of the world's most influential celebrities and entrepreneurs, tweeted directly at NASA's acting administrator, Sean Duffy. "Wait, what's the T on 3I/Atlas?" Her question, written in the spirited language of pop culture, instantly propelled the object into mainstream conversation. When a figure like Kardashian asks about an interstellar visitor, millions of people pay attention, and public discourse shifts. Her tweet signaled that the mystery of 3I/Atlas had crossed from scientific circles into broader cultural consciousness. Duffy responded swiftly and confidently. "Great question. NASA's observations show that this is the third interstellar comet to pass through our solar system. No aliens. No threat to life here on Earth." His response attempted to calm speculation, emphasizing that NASA sees nothing alarming or artificial about 3I/Atlas. Yet the very need for reassurance underscores how unusual interstellar objects still are and how little we truly know about them. On the same day, the highly respected Congresswoman Anna Paulina Luna took the matter a step further by formally requesting the release of NASA's highest-resolution images of 3I/Atlas. Her letter, addressed to Duffy and made publicly available, asked for the disclosure of photographs captured by the HiRISE camera on the Mars Reconnaissance Orbiter on October 2nd to 3rd, 2025. These images, with a resolution of 30 kilometers per pixel, represent some of the best observational data available for studying 3I/Atlas. Yet they have not been shared with scientists or the public, raising concerns about transparency. I personally reached out to Professor Alfred McEwen, the principal investigator of the HiRISE team at the University of Arizona, seeking access to the same data. However, I received no reply. The lack of communication is troubling, especially at a time when scientific exploration should remain open and collaborative. Political tensions, including the current government shutdown, should not be allowed to impede the flow of scientific information. Data of this nature is time-sensitive. The window for observing an interstellar object as it passes through our solar system is limited, and timely access to the images could influence how upcoming observations are planned. High-resolution data could clarify whether the object displays any unexpected behaviors, rotation patterns, structural anomalies, or non-gravitational accelerations that might suggest an artificial origin or at least broaden our understanding of interstellar comets. When information of such importance is withheld, intentionally or unintentionally, it not only delays scientific progress, but also invites speculation. People begin to wonder whether there is something unusual in the images, something NASA does not yet want to reveal. That is why timely transparency matters, not just for scientists, but also for policymakers and the general public. Humility in the face of the unknown should guide our approach. We know so little about interstellar visitors that any confident dismissal of anomalies risks undermining scientific integrity. During a television interview with Natasha Zuvs on News Nation, I mentioned that I would be glad to bring Kim Kardashian up to speed on all the anomalies associated with 3I/Atlas. The idea of bridging the worlds of astrophysics and pop culture may seem whimsical, but it holds a practical purpose. When influential figures express curiosity, they energize public interest in scientific discovery, encouraging a broader audience to engage with questions about the universe, extraterrestrial life, and humanity's place within a larger cosmic context. The anomalies associated with 3I/Atlas are worth exploring thoroughly. These include unusual brightness fluctuations, complex trajectory modeling, ambiguous measurements of its reflectivity, and early indications that its motion might not align perfectly with predictions for a purely natural comet. Each anomaly may ultimately have a mundane explanation, but only if the data is shared, analyzed, and debated openly. Right now, humanity stands at a moment where space exploration, technological capability, and public curiosity intersect more intensely than ever before. The discovery of interstellar objects like Oumuamua, 2I/Borisov, and now 3I/Atlas has transformed our understanding of the cosmos. We once believed that interstellar visitors would be extraordinarily rare, yet in just a few years we have observed 3. This alone suggests that the space between stars may be far more dynamic and populated with wandering bodies than we thought. Whether these objects are natural fragments from distant solar systems or, in rare cases, something more engineered remains an open question. Dismissing unconventional hypotheses too quickly does a disservice to scientific progress. Instead, we must pursue rigorous observation, open data sharing, and imaginative curiosity. Only then can we hope to uncover the true nature of objects like 3I/Atlas and determine whether they are simply cosmic debris or something far more profound.